right, this is going to be the recording for magnetic fields 3.2. And so you can see attendance and then the home page and the notebook pages and the exit ticket. Going into the home page. You can see all that's linked in here is the notebook pages and the exit ticket. There is not a warm-up for this unit, so you're going to want to, or not unit, but lesson. So you're going to want to click on these notebook pages, and that will bring you up to this. And so the idea is that there is two claims that we are looking at in this lesson. And so the investigation question is, what affects the amount of potential energy stored in the magnetic field when a magnet is moved against a magnetic force? And so this kind of piggybacks off of what we did on Monday or Tuesday, depending on when you have class. And so claim A says there is more potential energy stored when you're moving against the magnetic force of a stronger magnet. And you can see I highlighted and underlined a few parts of these to kind of help you break them down. And then claim B says there is more potential energy stored by moving against the magnetic force closer to the magnet. So the idea is claim A and claim B, they both have the magnet going against the force. So if you're trying to have two magnets attract and you're pulling them apart, you're going against the force. If you have two magnets that are repelling and you're trying to push them together, you're doing the opposite of what they want to do. So you're acting against the force. And so claim A says magnetic force of a stronger magnet. So they say stronger magnets have more force and potential energy. And then claim B says that when the magnets are closer together, there's more energy. And so it's pretty much A is stronger magnet, B closer together. And so like I said, I tried to highlight and kind of help you break that down. And then down here, it wants you to run some tests using the simulation that you can, that will support or refute the claim A or claim B. So you kind of need to decide which claim you think makes more sense. And then you're going to obviously conduct some tests in the simulation to help prove that that is a better claim. And then refute, down here, refute means to go against. So you're for one claim and you're against another. And so like I said, you're going to use the simulation to do that. So looking at the first claim, I'm going to have some ideas for you about showing magnetic force with stronger magnets. So obviously I'm going to have stronger magnets. And like I said, you could do a variety of things. It just wants you to describe a test you could do. And so what I notice is my two magnets are here and they should repel. So if I move them closer, obviously my number goes away. If I move them farther away, that number goes down. So we're in about the 7,000s. If I do that same thing with two weak magnets, I'm going to compare my numbers. So about 2,000, and if I take them away, it's still about 2,000. So it's obvious that my numbers are higher with stronger magnets. The other claim is that the potential energy is, there's more of it if they are closer. And so two weak magnets, when they're closer, there is more. And if I flip it around, so there's only more when they want to attract. So let me show you what I mean. So I have these two want to repel. So if I bring them closer, yes, there's more potential energy. And I bring them farther away, yes, there's less because they want to repel. And so, by letting them repel like that, I'm giving them what they want. So they don't want to be close like this because that is not what they want to do. But if I flip it and I have it so they're attracting, I have more potential energy as I'm moving it away because they want to be together. As soon as I let them be together, those numbers go down and they can almost go to zero when I have them attract all the way. So that claim is not 100% accurate. And so you are going to describe two tests, one here and one here, to either support or refute. So either to support it or go against those claims. And then down here, we're going to use the simulation again, and you're going to create a launcher. And so what you're going to want to do is you're going to want to have one magnet over here, and you're going to want to lock that magnet because you don't want it to move. And then you'll have your other one. And when you run it, you can see that that magnet will launch. And so your idea, you need to decide, do you want it close? Do you want it a little farther away? Are you attracting? Are you repelling? Because if you flip it and do attraction, it's not exactly launching, it's going to have it come together. So you want to play around with it and do the best launcher with the most potential energy. And so when I flip this back around, you're looking at this number up here. So you want to get the most potential energy that you can. You're going to take a screenshot of whatever idea you come up with, and then you're going to put it down here. The next couple slides have some evidence cards on them. And this is similar to what you did last lesson. And there's 3 evidence cards, but these ones have to do with a simulation. And so this one shows this thing called a sensor. And so in the simulation, you could put a sensor in between, and this is in the Analyze button, and measure. And so you can see both of these have repelling magnets, and we can tell by the magnetic field lines. Obviously, these are closer and these are farther away, and they want to repel, so we want this. And you can see this one is labeled 5, and this one is 58.8. So this means that there is a stronger force right here than right here. And so what it wants you to do is think about the potential energy over here. And there is more potential energy stored in this system right here because they want to repel. They want this. They want to be farther away. And as soon as they're able to be let go, then they will move far away. So there's more potential energy here. There's less here because they are farther away. In this one, we have repelling magnets, and so they are trying to push these two together, and it was harder to push as they got closer. And so why is it harder to push them together as they got closer? These two magnets want to repel. So the closer you push them, the more potential energy they have because they want to move away from each other. And as soon as they're let go, they will release that potential energy, and that will turn kinetic, and they will move away from each other. But being pushed together, they don't like it. So they're building up energy so they can go away from each other to repel. Then down here we have attracting. And so they're trying to pull these two magnets apart. When these two magnets, they want to go together. They want to attract, and so they're pulling them apart. So there is getting more potential energy because they want to come together, but they're being pulled apart. So it's gaining energy so that as soon as they're released, they can come together. And then the last slide is a reading about black holes, which I think is very interesting. And so you're going to read this, and then there are 2 questions. Why are black holes black? And then over here, why do astronauts on the moon seem like they're walking on springs when while on Earth we are firmly attached to the ground? So you will read, it's a short reading, and you'll answer those 2 questions. And then remember, when you're done with those notebook pages, you turn them in because we're doing them piece by piece because we're only really doing 2 lessons this week and then we're done because next week we're going to review and test. So that's why I didn't assign you a whole new notebook. We're just doing it day by day. There is an exit ticket and then that is it. So please use these exit tickets though as kind of like a study tool. Make sure it makes sense. Make sure you're kind of taking it again too because you get 2 attempts, so take it again if you miss anything. and kind of check and you see what you're doing, kind of use it as a check to see if you are on track.